$500 commercial drone just destroyed a $5 million tank. This isn't science fiction. It's happening right now, and it's changing warfare forever. For over a century, tanks have been the kings of the battlefield. Armored, powerful, and nearly unstoppable. But there's a problem. The weapon that's bringing them down costs less than a smartphone. And it's available on Amazon. This is the story of how modern warfare's most expensive weapons became its most vulnerable targets.
Ukraine, 2022. When Russia rolled in with thousands of tanks, military experts predicted a quick victory. They were wrong.
Ukrainian defenders had a secret weapon. Not expensive missiles. Not advanced tanks.
In the first 2 years of war, Russia lost over 3,000 tanks. Many fell to drones that cost less than their fuel tanks. Let's talk numbers. A Russian T-90M tank, $4.5 million. A modified FPV racing drone. This means Ukraine can afford to lose 9,000 drones for every tank destroyed and still come out ahead economically. But it's not just about cost. It's about physics, tactics, and a fundamental flaw in tank design that engineers never anticipated.
To understand why this works, we need to understand a tank's greatest weakness, its roof.
Modern tanks have incredibly thick frontal armor. The M1 Abrams front can withstand 800 millimeters of penetration.
Why? Because for decades, tanks were designed to fight other tanks. The threat came from the front and sides, not from above.
Yes, aircraft attack from above, but they're expensive, easy to spot, and vulnerable to air defense. They weren't the primary concern.
Enter the drone. Small, silent, nearly invisible to radar, and it attacks from exactly where tanks are weakest.
These aren't your typical camera drones. They're FPV racing drones, built for speed and agility.
The pilot wears goggles, showing a live feed from the drone's camera. They see exactly what the drone sees, in real time.
These drones can reach speeds of 100 miles per hour and turn on a dime. Try shooting that down with a machine gun.
Strapped to the bottom is a simple warhead. Sometimes it's a military grenade. Sometimes it's homemade explosives. Either way, it's enough.
When dropped or crashed onto a tank's thin top armor, the explosive creates a jet of molten metal that punches straight through.
Once inside, the explosion hits fuel tanks, ammunition, or crew compartments. The results are catastrophic.
Modern tanks have 3 or 4 crew members sitting directly beneath that thin armor. There's nowhere to hide.
So how did a racing hobby become a military revolution? It started with necessity and Ukrainian ingenuity.
In early 2022, Ukraine faced a massive Russian armored force but had limited anti-tank missiles. They needed a solution fast.
Civilian volunteers, many of them FPV racing enthusiasts, stepped forward with an idea. Weaponize our hobby drones.
Within weeks, they were modifying commercial drones in apartments and garages. No million-dollar R&D lab required.
The components? A commercial FPV frame, racing motors, a basic flight controller, FPV camera, and a video transmitter. All off the shelf.
Anyone with basic soldering skills can build one in a few hours. Instructions are freely available online.
The warhead attachment is equally simple. A 3D printed mount, some zip ties, and you have a precision-guided munition.
The pilot uses a standard RC radio controller and FPV goggles. The same equipment used for drone racing sports.
Training a pilot?
About 2 weeks on simulators, then field practice.
Compare that to years needed for jet pilots.
Because they're so simple, production scaled rapidly. Small workshops across Ukraine churned out hundreds per week.
Funding came from crowdfunding campaigns. Citizens donated money specifically for drone production, $500 at a time.
Support came from around the world. FPV racing communities, tech companies, and individuals all contributed. The designs evolved rapidly. Each week brought improvements based on battlefield feedback from operators. But having the weapon is one thing, using it effectively is another. Let's look at how these drone strikes actually work.
First, reconnaissance drones scout for targets. These are usually larger, camera-equipped drones that can stay airborne for hours.
When they spot a tank or armored vehicle, They relay coordinates to drone strike teams positioned miles away.
The strike team loads explosives onto FPV drones and prepares for launch. They work from concealed positions to avoid detection.
Launch is simple. Hand-thrown or catapulted, the drone gains altitude quickly and races toward the target zone.
Pilots fly low, using terrain and buildings for cover. This makes them harder to spot and nearly impossible to track with radar.
As they approach, the pilot searches for the target through their goggles. The high-resolution camera shows remarkable detail. Once locked on target, the pilot begins the attack run. They dive from altitude, building speed as they approach.
The final seconds require precision. The pilot aims for specific weak points: engine hatches, turret tops, or open hatches.
The drone crashes into the tank's top armor at high speed. The explosive detonates on contact.
Often, strikes come in waves. If the first drone damages the tank, follow-up drones finish the job or target the crew as they evacuate. Advanced teams use swarm tactics. Multiple drones attack simultaneously from different directions, overwhelming defenses.
And it's not just tanks. Artillery pieces, supply trucks, command posts, even individual soldiers, all are vulnerable.
The psychological impact is devastating. Soldiers know a $500 drone could kill them at any moment. There's no safe place.
So how are militaries responding? The answer reveals just how hard it is to defend against this threat.
Initially, Russia dismissed the drone threat. They believed their tank numbers and air defense would be sufficient.
By mid-2022, reality hit hard. Tank losses mounted into the hundreds, then thousands. Something had to change. The first solution? Cage armor. Welded metal grids placed over the tank's roof to detonate drones before they hit.
But cage armor has problems. It's heavy, reduces visibility, makes tanks top-heavy, and crews hate working around it.
Does it even work? Results are mixed. Some drones detonate harmlessly on the cage. Others punch right through.
The second approach, electronic warfare. Radio frequency jammers that disrupt the drone's control signal.
Jammers can be effective within a few hundred meters, but they're expensive, require power, and have limited range.
Plus, they can't jam everything at once. Attack from multiple frequency bands or multiple directions, and something gets through. And drones are evolving. Autonomous systems that don't rely on radio control are already in testing. Jamming won't stop those. Individual soldiers now carry anti-drone guns. These directed energy weapons jam or disable drones electronically.
The problem? You have to see the drone first. At 100 miles per hour, that gives you seconds to react.
Some tanks now mount automated machine guns for anti-drone defense. But hitting a fast-moving small target is incredibly difficult.
Here's the cruel math. Each defensive system costs hundreds of thousands of dollars. The drones they're defending against cost $500. Some militaries are fighting fire with fire, deploying their own hunter-killer drones to take out enemy drones.
This has created an arms race. Each advance in drones spawns new countermeasures, which spawn new drone capabilities. The implications go far beyond Ukraine. This revolution is reshaping military strategy worldwide.
We saw it first in 2020. Azerbaijan used Turkish drones to destroy Armenian armor. Armenia lost the war.
In the Middle East, Houthi rebels use drones costing thousands to attack ships worth hundreds of millions. From Yemen to Sudan, Myanmar to Gaza, cheap drones are changing conflicts everywhere.
Western militaries are scrambling to adapt.
The U.S. Army is completely rethinking armored warfare doctrine.
Some experts argue tanks are obsolete. Others say they just need to evolve. The debate rages in Pentagon corridors.
New tank designs include active protection systems, 360-degree sensors, and AI-powered threat detection.
Israel's trophy system shoots down incoming threats automatically. But can it track and stop a $500 FPV drone? Testing continues.
Each new defensive system makes tanks more expensive. The M1 Abrams now costs over $10 million per unit with upgrades. This makes the asymmetry worse. A $10 million tank versus a $500 drone is a 20,000 to 1 cost ratio.
Defense contractors who built billion-dollar weapons now face an existential question. How do you profit from $500 solutions? Military doctrine is shifting. Dispersed operations, constant movement, air defense priority. The tactics of tank warfare are being rewritten.
The answer isn't abandoning tanks entirely. It's integrating them into combined arms teams with comprehensive drone defense. Looking ahead, drone technology is advancing faster than anyone predicted. The future looks even more challenging.
Artificial intelligence is the next frontier. Drones that can identify and strike targets without human guidance.
Target locked.
Imagine 100 delivered autonomous drones together, sharing target data.
Facial recognition allows drones to hunt specific individuals. Military commanders, politicians, anyone can be targeted.
Loitering munitions like the Switchblade can wait airborne for hours, then strike when the perfect moment arrives.
Drones are getting smaller. Some new models are palm-sized but carry lethal payloads. How do you defend against something you can't see?
Range is expanding. Modern FPV drones can strike targets 10 kilometers away. Future versions will reach much farther.
Speed keeps increasing. Experimental drones exceed 200 miles per hour. At that speed, reaction time drops to nothing. Thermal cameras enable night operations. Darkness no longer provides cover. Tanks can't hide in shadows anymore.
For every countermeasure, there's a countermeasure. Frequency hopping radios defeat simple jammers.
Production is industrializing. Automated factories can produce thousands of military drones monthly at decreasing costs. Within 5 years, this technology will be everywhere. Every military, every militant group, possibly even criminal organizations.
Security experts worry about terrorism. What happens when extremists have access to precision-guided weapons for $500?
Regulating this technology is nearly impossible. The components are commercial. The knowledge is freely available online.
Pandora's box is open. There's no putting this technology back. The question is how we adapt to this new reality. So what does all this mean? 3 key takeaways will shape the next decade of warfare. First, economics now matter more than firepower. The side that can field 10,000 cheap weapons beats the side with 100 expensive ones. Second, innovation speed beats raw capability. Militaries that adapt quickly will win. Those stuck in old doctrines will lose badly. Third, concentration equals vulnerability. Massing forces, once a strength, is now a fatal weakness. Dispersion is survival. Are tanks dead? No. But they can no longer operate as they did for 100 years. They need layers of protection and support. Future armored forces will integrate electronic warfare, active protection, drone screens, and AI defense. It's expensive but necessary. Smaller nations gain leverage. You don't need a massive defense budget to field effective forces anymore.
Defense contractors face disruption. A Ukrainian garage workshop shouldn't outperform Lockheed Martin. But sometimes it does.
Ukraine has become the world's laboratory for modern warfare. Every military is studying these lessons intensely.
Even Russia is learning. Their drone production ramped massively. They're now fielding thousands of similar systems.
China watches carefully. They're the world's largest drone manufacturer. They understand this revolution's implications for Taiwan.
NATO is urgently upgrading. Every member nation is reassessing armor doctrine and investing billions in counter-drone systems.
Military budgets are shifting. Funds flow from traditional platforms to drone production, AI integration, and electronic warfare.
Training is changing too. Simulator time replaces field exercises. Drone pilots train at desks, not in tanks.
Ethical questions multiple. Should autonomous drones decide who lives and dies? Where do we draw the line?
Arms control becomes nearly impossible. How do you verify compliance when the weapons are built from hobby parts?
That $500 drone destroying a $5 million tank isn't just a battlefield tactic. It's a revolution in how wars are fought.
The age of invulnerable armor is over. The era of asymmetric warfare has arrived, and it was delivered by a device you can buy online.
The only question left is, how will your country adapt? Because this revolution isn't coming, it's already here.